This is a continuation of section 5.3. We're going to now look at the probability of at least one. In this example, there are 8 dogs at the dog park, and we're to find the probability that at least one is male. So our sample space would be all the possible outcomes of this procedure. If you're determining how many dogs out of 8 are male, these are your possible outcomes. You find that none of them are male, 1 is, 2 are, 3, all the way to all 8 dogs are male. So, what is the probability that at least one is male? So, the probability of at least one of the 8 is male. And in words, that's just writing that out. At least one. So which of these numbers are at least one? Well, 1, 2, 3, 4, 5, 6, 7, and 8. So we would say that's the probability that we found that 1 was male. Or let's say let me do it this way. Probability that 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. All of those, if we found any of those outcomes, then we found at least one. Because 1 is at least 1, or 2 would be at least 1, or 3. And what does or mean? What operation do we do when we read the word or? That's addition, right? So now we've got to do the probability of 1 plus probability of 2 plus that's a lot of work. There are 8 of them. What if it were 20 dogs, right? So let's go back and look. We want 1 or 2 or 3 or 4. What's the only thing we don't want? The only thing we're not interested in when we say at least one is 0. Well, you remember what the probability is for the sum of the sample space. If I take the probability of every one of these and add it up, that should be equal to 1. So I want everything except this. So if I do 1 minus the probability of 0, then I would have all of that, because that's everything else. They're complements. 1 through 8 and 0 would be complements. So if I just take out 0, I will have 1 through 8. So in general, we say the probability of at least 1 is equal to 1 minus the probability of 0, or another way we can say it, we can kind of make it rhyme, 1 minus the probability of none. 0 meaning none. So this is the shortcut way to get that and not have to find all of these, because 1, 2, 3, 4, 5, 6, 7, and 8, all of those would be at least 1. So this is what you need, either one of these two, but you need to know to be able to compute probability of at least 1.